Connected in 3D, Real-Time Solutions and Digital Twins podcast with your host, Ashley Crowder.
Welcome to Connected in 3D, Real-Time Solutions and Digital Twins. I'm your host, Ashley Crowder. Every Wednesday, we have a new expert from the 3D space to dive into different topics to help you scale 3D and digital twins across your business to reduce costs, increase speed to market, and improve maintenance, training, and sales. And today, I'm so excited to have Leonard Daly, who's been working in 3D graphics for 44 years, which is incredible. He's a 3D systems architect and consultant specializing in open systems integration for XR, commerce, and GIS applications. Through his company, Daily Realism, he collaborates with leading organizations like the Khronos Group and Open Geospatial Consortium to develop and promote open standards for 3D model transmission and display. Leonard's work focuses on advancing technologies such as glTF, OpenXR, and 3D commerce to drive innovation and adoption across industries. Leonard, thanks so much for joining us.
Well, thank you very much, Ashley.
Yeah, so we can just jump right in. I mean, 44 years is incredible. How did you start your journey into 3D graphics and XR architecture space? What sparked your interest in the field?
It went back to college. It had a very specialized system that did advanced 3D graphics at that time, which was wireframe. Not because they wanted to see where all the edges were, but because that's all that could be done. So it was drawing lines on screens and moving them around. I was touching that when I finished college. My first job was not in so much directly 3D graphics. They were very much doing printing, plotting. So it was using the computer for 2D graphics, but very quickly we started realizing that some of the data that we had to analyze and display looked better in, well, at least since we had no digital display devices, but we could plot, we could generate 3D oriented plots, things like perspective views or shaded surfaces to give you the impression of 3D, because it provided more information to help to drive the analysis.
That's awesome. That's amazing. It's that's where it started. Now today we can have full on video games and like realistic animations, and I'm sure you've seen it all at this point.
Quite a bit.
Yeah. And I know you work a ton with the Khronos Group, particularly on 3D commerce and glTF standards. Can you just explain the importance of glTF and why it's becoming so widely adopted?
So glTF provides the transmission or the last mile format, taking from a distribution computer down to the user's end, and is designed to be very efficient going into the graphics card where all the real work is done. So it's not like you deliver a bunch of instructions to a computer that then has to be interpreted, rearranged, processed, and then sent to the GPU, but the data that comes in is delivered directly to the GPU. So it was designed to be very efficient in that respect. As a result, a lot of the efficiencies that are done there preclude it from working in other arenas. So we've working closely with primarily now USD to provide a lot of the authoring support. So we're working really closely, and by we, I say the 3D Formats, which is the group that oversees glTF, with USD and the Alliance for OpenUSD, to develop a continual system so that artists and other practitioners can develop 3D spaces, whether it be a model, an entire space, something that's a partial system that goes into an XR display. Develop that and have all the authoring features that you want. And then when you're ready, you sort of push a button and make it available for mass consumption.
Yeah, and it's so important. I mean, taking one step back, the Khronos Group is a nonprofit helping to create these standards for glTF and others, and then OpenUSD is another group. And we get this question a lot of well, should I do USD or glTF? And it's well, it's not one or the other. It's both. And to your point, glTF or GLB, it's so efficient. It is that publishing platform. So for the web, for Android AR, for some of the XR experiences, anytime you're wanting to share that file, really, glTF is probably the best format to go to. But USD is a lot more complex, and so it gives you a lot more opportunity for collaboration and editing and authoring. And I actually will have someone on here next week talking about OpenUSD. So it's good.
So glTF has been described as the JPEG of 3D graphics. And that analogy is very apt because if you think in the larger space, the authors, the artists are not going to want to work at JPEG level because of all the compression involved. It's very efficient to get to your device, whether it be something very small like a phone, or you have a very large pipe and a big computer to display it. It's still one of the most efficient means to get it there. But to authoring in that format, you have to be concerned that all the smooth edges you draw, the lines you draw, may actually get compressed away. So you want to author something where you can go back, see the layers, be able to manipulate one thing without having to worry about what am I overwriting. Just work in a real authoring environment, and that's where the Photoshop or the other artistic-oriented formats come in. And then when you're done, you can certainly deliver a Photoshop format, but most devices can't directly support that. So you want to deliver a JPEG format. And then on top of that, it also helps protect your intellectual property that you invest into the system, whether it be the strictly system, flat artwork or a 3D model. By going to a glTF file or GLB, and we can get into that difference in a little bit, the art or the intellectual property that goes into how you design something and what the details are can be easily optimized out. In many cases, that's not really important for the appearance of the items, but it's really important for its function. And glTF is mostly concerned about the appearance.
Yeah, that's a really good point. And we work with a lot of like industrial manufacturers who they don't, it's not really the art, but it's the IP behind their CAD designs. And they are really happy that they are able to optimize out a lot of that detail and just provide a visual GLB file so that their prospects and vendors can quickly see what this, how this pipe fitting works and how it gets installed, but they're not giving up their IP, which is huge. So, um, makes sense across a lot of different industries. And, working within the Khronos Group, helping to develop this, what are some of the challenges in creating viewing consistency across different displays, devices, and 3D viewers?
Well, starting with the simple point that everybody's device is different. Even if you happen to have two Androids or two iPhones right next to each other, things are not going to look identical. If they're brand new factory shipped just out of the box, they'll look very close. But as they age over time, depending upon the environment you keep them in, whether you get exposed to lots of bright lights, high temperatures, the displays will degrade at different rates. And the same thing applies to desktops and laptops. So every device is going to look different. Each manufacturer may put a slightly different color tint, what they define as the default to their display device. So you can't say that this is going to look, Pantone number something blue exactly on every possible device because it differs. And on top of it, it differs in the environment you're looking at. So if you take a phone and you're working inside where it's relatively dark, you can see things that are pretty bright. But you walk outside and all the fine details and the colors tend to get washed out, and you need to see bigger things. So just that part makes the whole consistency discussion very difficult. On top of that, different engines will render models slightly differently. They may apply slightly different equations to generate the colors or the shadings, and they're all correct in the sense that nobody's wrong as long as people. So the idea is to get everybody really close to about the same thing, so that when you're in a nice environment, nice being typically indoors, not lit into your face, not lit directly on the screen, that things are going to look blue within the range of what people call blue or variations of blue.
Right. Yeah. I've explained this to especially some of our fashion clients who color is extremely important in that texture, and this red needs to be exactly this red. Well, especially when you're looking at real-time environments, the lighting environment affects that so much. To your point, if you're outside during the sunset versus midday, your
Mhm.
white t-shirt is going to look slightly different, and so that lighting consistency. And I know with the Khronos Group, you guys have been doing a lot of work on trying to create that consistency, at least with the viewer certification, so that if you have a 3D viewer and you're viewing GLB in it, ideally if it's Khronos certified, there's some more consistency there.
And that's correct. And we're going to a new method rather than just hard against a standard, because the standard changes over time as algorithms improve, as capabilities improve. So we're going to a comparison standard where you get to compare your engine, your rendering engine, against other standard accepted rendering engines. And even in the end, your engine can be included as part of the displays. So right now, there's a site up there at Khronos that it will post the URL later on that shows the differences of displays of how the same model looks in 5 to 7 different rendering engines, including at least one uh, ray tracing engine. The work that's undergoing right now is to expand that site, make it more usable, still keep the same functionality, and we'll expand the functionality later. So I know this is kind of dated. So this is right now November 2024. Um, if you see this in a bit of time, you may see the actual updated things or things with much more functionality.
I'm really excited for that, to quickly show, especially people who are new to 3D, this is what we mean by rendering in different render engines can look slightly different.
Yeah,
That'll be really, really helpful.
and when
That's
you one thing is that when you look at those models individually, none of them look wrong. They all look really good. And what we found is since Khronos instituted the, the acceptance testing and the conformance program, and this was back in 2001, 2002, 2021, 2022, the rendering engines have gotten much closer into what they decide, what they will display. There's not exact comparisons. In other words, if you subtract one picture from another, there's going to be differences, and we don't. That's fine. That's to be expected. That represents different ways of thinking about the same thing. In some sense, it's like looking at two different people looking at the same object and having slightly different perspectives of what colors and what shadings are important, and how their eyes work, what color lighting they happen to get, and what's important to them in terms of textures.
Yeah, it's always subjective at the end of the day. Um, and turning gears a little bit, can you walk us through some of the most promising applications of 3D graphics in the geospatial context? So, how do these technologies enhance user experience and interaction?
So there's a number of work, um, different directions of work going on. The biggest work is that has widespread user applications is in city planning, where you get to build up cities, and when there's new buildings going in, it's not so much for seeing how the city infrastructure supports, but when somebody builds a new building, here in Los Angeles, they're building a new art museum, and it's going to be crossing a major street. And so one of the concerns early on was, how is that going to affect the sight lines? Does it actually look like it belongs to an art museum? Is it going to cause traffic problems and visibility problems? So for the average person who can't see that, who can't mentally visualize that design, this becomes much easier. And instead of having a physical model that somebody builds, where you have to go to the model wherever it happens to be to see it, this is something that people can look at from their computer. So if you're more access limited, you can't get around very much, and you live 40, 50 miles away, you can still easily see what it's going to be like for your perhaps annual trip to the art museum, and see what you can be excited about.
Definitely. And that's huge because so many different buildings or different parts of the building might be designed in various different CAD software. And if you don't have that software, you can't open it. But with web-based
Yeah.
GLTF, yeah, you can, which makes it a lot more accessible. And in your view, what are some of the key components of a successful XR architecture? So if you're trying to go about, hey, I want to set this up within my company to be able to view 3D across, AR, XR, web. What are some things people should be thinking about?
So I've seen many places start off saying, "Oh, we need to get into 3D." Um, now I guess the current phrase is, "Oh, we need to get into AI." There's
Yeah.
always we need to get into without really thinking about why you need to get there. Um, how does it how does it improve your business? Is it something that you need to do because you are a leading edge company and you need to show that you are really there? Or is it something that you need to do because you want to improve a user experience or a customer relation? Figure out exactly why you're doing this. If you're making an app to be um, you're a small organization, you're making an app to add to the collection, you hope that it takes off and you can make millions of dollars on that, then make sure that you understand what the people who are going to either buy or otherwise use the app want, and what the people who are providing the money, whether it's advertisers or the purchasers of the app, or somehow you're connecting it up to something else, what they'll get out of it. There are many cases that people will develop an app not just because to show they can, and that's a useful thing. But then keep in mind the scope of the project. If you're trying to do something to show you can do it, sooner or later you want a paying customer. So you don't want this project to become so large that it consumes all your resources and you can't make it back to customers.
Yeah. And so if you are, say, at the flip side, say you're a customer, you're a manufacturer of shoes or a manufacturer of, you know, manufacturing equipment, industrial, how would you start? So, starting with what 3D design software you're in, and then how are you going to go about choosing an avenue to publish and share? And what does some of that decision and architecture planning look like?
So from the retail perspective, the primary need and use for 3D is to present your products. In long time ago, everybody printed out paper catalogs, and you'd sit there and look through the catalog and pick out the items you wanted. And it was restricted to one, maybe two views of an item. Colors were limited to what you could actually do in print. It was, if it's clothing, it's typically all folded up, and so it looks great, but it doesn't really tell you what the weight and the feel is, how it moves. Um, then came photographs, and at least then you eliminated your printing expenses. You had to host the photographs, but web hosting with the associated commerce is still cheaper than running out large catalog runs every year or multiple runs. With 3D, it gives the option at the simple case of allowing the consumer to easily visualize the model, visualize the item. For some things that are not a big deal, let's say like paper towels, pretty much people know what paper towels look like, and there's not much point in doing that. But when you get to more fancier objects, particularly objects that take up space, people want to know exactly what it's going to look like in their intended space. So if and this has been done by IKEA, Wayfair, Target, several other manufacturers or retailers. They will take their larger items, couches, tables, sofas, things like that, and allow you to visualize them in your room. So they run the camera phone, you run your phone, use your camera app, it reads what's in the scene, and then inserts their object. And so you can say, oh yeah, this is too big or too small, or it doesn't fit with something. And the big point there is it doesn't so much increase sales of that particular item, but it reduces returns, which is another major expense. So you have to figure out, like I said before, why is it that you're doing it, and where do you hope to get costs? So it's either a cost reduction, like reducing returns, or it increases sales because it provides something to a user to a customer that they hadn't seen or thought of before. And so,
Completely.
as your sofa, it may realize that you have a blank wall behind your sofa, and then suggest some sort of artwork to go on the wall. The artwork is an increased sale; it's an upsell, whereas the lack of return on the sofa is now a cost reduction. So you get two points out of that one. And that's on the retail end. The industrial end is significantly different. So go ahead.
Oh, no, go ahead.
On the industrial side, there it's more on. It is somewhat does the equipment fit, but it's also to make sure of how the equipment integrates in with the rest of the thing. Very little equipment is standalone and needs to be either integrated in through some sort of piping, either for liquids or for air, electricity, some other systems, and you need to make sure everything is tied together. Yes, you can get blueprints, but sometimes it's much easier to see what your whole industrial floor is going to look like. It also does make it easier when communicating with clients, people who are already signed up. They're agreeing to purchase things. They've signed an NDA, so you feel more comfortable about sharing your IP with them because there's a legal protection.
Right. And with either retail or industrial manufacturing, as people are starting to stand up more of their 3D architecture, are there any pitfalls to avoid or advice there?
So Khronos, in this last year, put together a series of 4 videos related to retail commerce and 3D retail. And you can find those on the Khronos YouTube site in the 3D commerce section. Those will do much better than I can do, and they go into a lot more depth. So rather than try to repeat them, the biggest pitfall is make sure you understand why you were doing this. And when you have it done, since you've invested quite a bit of money and effort to get your 3D models done, feature it on your site. Don't hide it down below. Don't make it, if you have a carousel of things going across the top of your page, don't make it the third or fourth one. Make it the only one.
Yeah, I hate when I see that a brand's invested all this, but then they're kind of afraid to put it at the forefront and they hide it in their website. And then they're like, well, the data, nobody used it. I'm like, nobody could find it.
Right.
We didn't know where it was.
It's like the whole point of video. When sites first went to video, started using video backgrounds and video banners, there was a reluctance to do so. And some of it was justified because video is a greater bandwidth item than static pictures. But that's not completely the case with glTF and GLB. When you use them correctly, you can get them down into the range of, let's say, under 5 megabytes. That doesn't mean that your highest quality, highest detailed item is going to fit that range, but you can get things across that look very good at that range. And then as the user investigates it further, you can provide a lot more detail.
Yeah, and with our optimization, we can help get it really small with still some detail. But it is interesting what people learn. One of our clients, refinery clothing store, added 3D to their website, and they were tracking all the data and realized that over 90% of the consumers were zooming in really, really close to the logos and the button on the shirt. And so it actually changed the way they did their photography of all the clothes because they never had close-ups of that before. So there's a lot of interesting benefits. And speaking to that, I mean, where do you see 3D standards and open formats like glTF playing in the future of immersive technology and digital commerce?
Well, it's the only way that different applications are going to be able to work together. If you imagine buying a lamp and having to get a plug specific for the ones in your house, or maybe in 3 rooms of your house because you had it remodeled and changed some of the other plugs. There's no way that it would ever work out. And electrical components would be so rare because there's so many different ways to do it. Or alternatively, you've had a lot of bare wires as people just cut off things and stuck them in wherever it fits. So
Yeah.
for safety purposes, for interoperability, you have to use the standards. Now, open standards are nice is because that there's no cost to read them, there's no cost to use them, and to build things based on them. There are other standards that are very useful and that are quite widespread that do have costs associated with them. But what's been found in the industry is that those standards that have costs, they have to make their models such that the consumer, the end user, is not responsible for the cost or not directly responsible. So, for example, a number of the audio formats do have costs associated with them, but the cost is paid for by the devices and the computers that will handle it, not by the user that may listen to it. Otherwise, all your music, you'd have to distinguish between all your music streaming services and video
That'd be
streaming
terrible.
services and podcast services and everything else.
Yeah, that would be terrible. And glTF is open, which is great. What's next for you and your work with the Khronos Group? Are there any upcoming initiatives or developments in 3D standards we should be keeping an eye on?
So for glTF, Khronos does almost all, meaning well over 90% of its work, out in the public, primarily in the GitHub repos associated with that. And so by, even though I may say something right now, you can go and take a look at it, even though we're not released officially. It hasn't been released as a ratified standard. One things, besides additional advances in the physically based rendering that are going on, there's in the whole structure of things, there's interactivity. Interactivity is very important because it allows you to build configurators. So you could take a bicycle, for example, just a bike frame, and then from a list of parts, pick the cranks, pick the derailleurs, pick the wheels, the whole set of things there. Whereas if you had to do that individual models, you'd be swapping in and out models all the time. And what may be a 5 megabyte experience with a bike now turns into 200 megabytes or a gigabyte. And that's not really acceptable. But on the other hand, if you start with small models, then each piece may be 2 or 3 megabytes, and at the end, by the time you swap through 20 different parts of different kinds, you may be up to 30 or 40 megabytes. But it's over a course of time, and this is things that you chose to put on there as opposed to somebody forcing you to consume. That one's really big. That one, the interactivity is coming out. There are a number meaning like 2 or so, viewers capable of displaying it, and also systems that are working with the actual software uh, data to define it, so you can work in 2 ways. And that does include the beginnings of early editors. So you're not having to write all the data by hand, which is not really acceptable.
We're really excited about that. I mean, we've done a number of 3D configurators for clients who can use our API to pull different parts of an asset from the asset management platform into the viewer. But it's still a ton of work writing out that business logic, and it's custom for every single client. So whoever you're talking about configurators, it's a very custom job right now, no matter who you're working with. And so I know we're really excited to see how the glTF new standards can help streamline this, because it is that configure price quote is helpful across e-commerce and industrial for sure.
There's a couple other pieces that are coming out. They're trailing behind because interactivity really did need to come first, and that's adding physics simulations. So, and this is hesitant. I don't really want to say that this will allow you to simulate clothing as it's draped over somebody and draped over somebody else. And that's a really extensive calculation, and we're not going to promise that. But it does allow you to simulate bouncing balls, things that are harder surfaced and that don't flow and deform as much. So that'll be really useful in certain environments. And then more with the interactivity and the configurators is a effort we're calling complex scenes that allows the integration of multiple and at runtime determined which pieces of a much larger scene get assembled together. So you can swap in and out things. It's what enables the full configurator to work easily.
That's great. So whether it's seeing, a piece of jewelry and you're swapping out different rings, like to stack rings or pieces, components, or an entire factory where you're pulling out different options and pieces. But that helps enormously. That's super exciting.
Yes, and so there's a lot of technical issues that need to be resolved, and we believe that we're not going to resolve all of them right off the first go. But again, the work is public. We do accept comments, particularly things that say use cases, saying this is what's really important for me, and this is why it's important. This is how we need it to work. That really drives how we do our developments. And so Kronos does not go out and invent things that have never been done before. That's the job of research labs, universities, and companies that pursue that work. But what we take is we see what has been developed and see where they're not quite working together correctly and work on that and come up with a solution that's acceptable to everybody.
Yeah, that's so exciting. And I won't hold you to any dates, but for those listening, where again can people find you and more about the Khronos Group if they're interested in learning more or contributing?
So Kronos is the best place to start for Kronos is their website, khronos.org. And you, if you need to reach somebody, you can always go and do a contact, and the people that directly receive the contact forms know how to pass it off to the person or the group of interest. There's also the Khronos GitHub, which is github.com/Khronos groups, and then this is where everything. I don't want to go into there because there's like 30 glTF repos, and there's a whole bunch of Vulkan, which is another part of Khronos. And so, but you can search for things you want from there and find it. We look for a variety of responses, capabilities. We're always open to accepting new comments. My website's realism.com, and you can reach me through there, the contact form. And at some point, my email address got entered on this, but I'm not sure where that goes.
Well, we can include some links to your contact information on the page when we launch this. But Leonard, thank you so much. This is so helpful, especially for people just starting to figure out what they want to do with sharing 3D, and then for those developers wanting to get in the weeds and help contribute to Khronos. Please help, because there always needs to be more input. So thank you so much for joining us. I really appreciate it.
Thank you, Ashley. It was a pleasure to be here.